So today we're going to talk about domain and range. Your domain is what your x values can be. And your range is then what your y values can be. Okay? This helps us with our functions and our function notation. Remember that a relation is a function if it doesn't have any repeating x values. Okay? Or remember it passes the vertical line test. So vertical line test is determining a function. If it touches it in more than one place, it's not a function, which means that it's going to have repeating x values. Okay? All right, let's look at this one. So determine the domain. Domain is what your x values are. Well, for this one, I have a stopping point for my domain. So that's 1, 2, 3. So that's a -3. Oops. Sorry. That is a -3 to positive infinity. Okay, so everything greater than or equal to -3. The range here has no stopping values, so it's just going to be infinity. So negative infinity to infinity, or remember all real values. Is this a function? How I determine that is I draw a straight line through the graph, and it touches it in two places, so this is not a function. Okay, so function notation just is another way to write a linear equation or a quadratic equation or a square root, an absolute value, how to write an equation. Okay, so if I wanted to evaluate this equation, I have f of x is equal to -x minus 7. And what I'm going to do here is I'm going to plug 5 in everywhere I see a x. So I'm going to have -5 minus a 7. So -5 minus a 7 is going to give me a -12. And remember that represents an ordered pair, so your input is 5 and your output is 12. Okay, if I wanted to evaluate -5, it's going to be negative times -5 minus a 7. So that's going to be a 5 minus a 7, which is a -2. So it's an ordered pair. -5 is my input. -2 is then my output. Okay? Okay? So zeros of functions is where the function equals 0. So where f of x is equal to 0. So basically where the graph crosses the x-axis. So that what you're looking for is the x-intercepts. Okay, let's look at some graphs and determine the x-intercepts, or the zeros of the functions. So here's the zero of the function where it crosses the x-axis, and where it crosses the x-axis is going to be at -3. So x here would be equal to a -3. Remember that's could be an ordered pair, -3, comma 0. Okay, over here the zeros of the function are where this graph crosses the x-axis. This is a quadratic equation, so where it crosses the x-axis is going to be at -1, 1, 2, 3, 4, and a 4. Or the ordered pairs -1, comma 0, and 4, comma 0. Okay. If I wanted to find the zeros of the function, you're going to set it equal to 0, right? So if I wanted to find the zeros of the function, I would say 0 is equal to 2x plus a 2. And I would solve for x, so move them. So it's going to become a negative 2x is equal to a 2. Divide both sides by negative 2, so x is going to be equal to a negative 1. Okay? So what about this one? And now we can know what this means. That is a 40 there. Sorry. X squared plus 3x minus a 40. So if I'm going to find the zeros of the function, I'm going to set it equal to 0. So how do I solve this now? Now I'm going to solve this by factoring. So what multiplies together to be a negative 4 and adds together to be a 3? Okay, that's going to be 8 and negative 5. Set both of those equal to a 0. So x is going to be equal to a negative 8, and x is going to be equal to a 5. Okay? Alrighty, slope. So zeros of functions, and then it's basically where it crosses the x-axis, and then now slope is your rise over your run. It's the steepness of your graph. Okay, remember a line that goes up and down is going to have a positive slope. A line that's decreasing is going to have a negative slope. A horizontal line is going to have a 0 slope. Okay, and then a vertical line is going to be undefined. Okay, so let's look at this graph and find the slope here. So we're going to go, it's increasing. Okay, so it's going to have a positive slope. So we're going to do our rise, which is 1, 2, 3, 4, over our run, 1, 2, 3, 4, 5. So our slope here is going to be 4 over 5. Okay. Remember, the other way to find slope is through ordered pairs. Okay, so if you have an x1 and a y1, and you have an x2 and a y2, you can find the slope by using the slope formula, y2 minus y1 all over x2 minus x1. Okay. So if you wanted to find the slope between the points 9, negative 3, and 11, negative 7. Okay, so we have a x1 and a y1, we have an x2, and we have a y2. So your slope is going to be your y2, so it's a negative 7 minus a negative 3, all over 11 minus a 9. So negative 7 minus a negative 3 turns into a plus. So negative 7 plus a 3 is going to be a 4. Okay, and 11 minus a 9 is going to give me a 2. So 2 goes into negative 4, negative 2 times. So your slope here is going to be decreasing from left to right. Okay, also we have our equations of lines, so we have our slope-intercept form. Okay, remember that's y equals mx plus b, where our m is our slope, and b represents the y-intercept. Okay. So if I wanted to find an equation of a line that had the slope of a -1/2 and a y-intercept of 0, -2, then this formula would be y equals your m, which is a -1/2 times x, and this would be your b, minus a2. Okay? Standard form. Okay, is when the x and the y are on the same side. So you could solve this equation for y and get the equation in slope-intercept form. Okay? You could also find your x and y intercepts. Okay? Your x-intercept is when y equals 0, and your y-intercept is when you let x equal 0. You can solve this equation for y, and you can get it in the slope-intercept form. Okay? So let's find the intercepts here. Okay, so I want to find the x-intercept. So I'm going to let y equal 0. So I'm going to have 4x is equal to an 8. So x is going to be equal to a 2. So the x-intercept is going to be 2, 0. The y-intercept is when x is equal to 0. So I'm going to have y equals an 8. So it's going to, my ordered pair is going to be 0, 8. Now if I solve this equation for y, then it would be in slope-intercept. Just get comfortable with that as well. So subtract 4x on both sides. So y is going to be equal to a -4x plus an 8. Okay. So graphing linear equations, we are going to use, there's different ways that you can graph linear equations, but we're going to use getting it in the y equals mx plus b form. Okay. Plotting the y-intercept, so you're going to plot the y-intercept. And then use slope to find another point. Okay, so this one is not solved for y, so we're going to have to solve it for y first. So we're going to move the x to the other side. So when we move the x to the other side, it becomes a -x. And then we're going to divide both sides by a 2. So we're going to get y equals a -1/2 x plus a 2. Okay, so we're going to plot the y-intercept, which is a 0, 2. Okay, then we're going to use the slope, which is a -1/2. So we're going to go down 1 and to the right 2. Okay, keep going down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And keep going in both directions, right? Okay, and then we can draw a straight line through here. Okay. All right, what about horizontal and vertical lines? So x equals the negative 7. So anytime you only see just an x, that's going to be a vertical. And when you see just a y, it's going to be a horizontal. Okay, so vertical x equals negative 7, so it's a negative 7. And no matter what, it's going to be a straight line through negative 7. Okay. Horizontal over here, y equals 1. So here's my 1. It's always going to be a 1 no matter what my x value is. So it's going to go through the y-axis. Okay. So that is review day 2, pretty much. All right, y'all have a great day.